Welcome back, dear students. This is our second video for this week. By the way, I'm Mr. Florendo, your Algebra 1 teacher. Today, week 13, we will discuss about simplifying rational expression in chapter 11, lesson number 1, that is on textbook pages 664 to 669. Materials needed: your textbook, notebook, and your pen. Objectives: to define rational expressions, simplify rational expression. Before we have the example, let's take this one as a short of a recap or review. Simplify each expression. Number 1, 12 over 40. So when we simplify this one, what do you think is the simplified form of 12 over 40? What is the GCF that can divide your numerator and denominator? That could be exactly 4. So when you simplify 12 over 40, that's 3 over 10. 12 divided by 4, that is 3. 40 divided by 4, that is 10. What about the second one? 24 over 60. What is the GCF or the simplified form of this one? Yeah, that's correct. 2 over 5. What is the GCF here? That is 12. 24 divided by 12, that is 2. 60 divided by 12, that is 5. Next example, factor each expression. If I will have x squared plus 5x plus 6, how do we factor out this one? Since the leading coefficient here is 1, just find the factors of 6 whose sum is 5. So that could be 2 and 3. So we will have this one as x plus 2 and then x plus 3. The second one, fourth, 4x squared minus 64. As you can see, we do have monomial factor here, that is 4. You can take out 4 and then factor out if the remaining factor can still be factored out too. So if we are going to take the factored form of this one, take out 4, what is left here is x squared minus 16. X squared minus 16 is the difference of two squares. So we can factor out that one as x plus 4 and x minus 4. Number 5. 2x squared plus 3x plus 1. So what are the factors? Since the leading coefficient here is not 1, do not find the factors of 1 that would give you a sum of 3. Instead, get the product of this one and then rewrite the middle term. So the possible factors of this one would be 2x plus 1 and then x plus 3. You can check that one. 1 times x, that is x. 2x times 1, that is 2x. Add that one, the sum is equal to the middle term. Number 6. Check first if you have a monomial factor to factor out. 9, 60, and 100. So we don't have. Observe 9x squared is a perfect square. 100 is also a perfect square. Check if the given quadratic polynomial is a perfect square trinomial. So since your A here is 3x, 3 times 10, that could be 30, double this one, that is 60. Since the middle term is 60, so this is a perfect square trinomial. So when you factor out a perfect square trinomial, that is 3x plus 10 raised to the second power. So now let's define what is a rational expression. A rational expression is an algebraic expression whose numerator and denominator are polynomials. Way back in our lessons about polynomials, we define polynomials as sum of monomials. So if we're going to describe what's a monomial is a monomial is a number, a variable, a product of a number consisting of one or more operation with whole number exponent. The value of the polynomial expression in the denominator cannot be 0 since division by 0 is undefined. This means that the rational expression, like rational functions, may have excluded values. By the way, when we say excluded values, that is the value of your variable in the denominator that makes that one equal to 0 and that makes the whole expression undefined. Let's take the first example, identifying excluded values. Find any excluded values of each rational expression. The given is 6 over g plus 4. So the step number 1, set the denominator equal to 0. So in this expression, the denominator that we have is g plus 4. So we will have that one. Set your denominator, g plus 4 equals to 0. And then solve for g by subtracting both sides by 4. So we will have g equals to negative 4. Therefore, the excluded value of this expression is negative 4. So that value of your g will make the expression undefined. Another example, 3k squared over k squared plus 7k plus 12. Again, you're going to set the denominator equals to 0. So we will have k squared plus 7k plus 12. So this is a quadratic equation. So when you have a quadratic equation, if that can be factored out, then factor out. Check first. Check the possible factors of 12 that would give you a sum of 7. Do we have that one? Yes, we have. What are those factors? We have 4 and 3. So the factored form of the left side, that is k plus 4 times k plus 3. 4 times 3, that is 12. 4k plus 3k, that's 7k. So after factoring that one, use the zero product property to solve for your k. So k plus 4 equals to 0, k plus 3 equals to 0. Then solve each equation for k. K therefore equals to negative 4, and the other one, k equals to negative 3. Therefore, the excluded values of this rational expression are negative 4 and negative 3. So that means when your k is negative 4 here, the whole expression will be undefined. And the second one, when your k is negative 3, the whole expression is also undefined. Another example. Simplify each rational expression. If possible, identify any excluded values. 2r raised to 4 over 14r. First, factor 14 or factor your numerator and denominator. So we will have that one, 2r raised to 4 over 2 times 7r. We factor out first 14. The next one, divide the common factors. Okay, divide the common factors. Note that if your r is equal to 0, the expression would be undefined. So therefore, that r is your excluded value. Further, when we simplify this one, that could be simplify and then find the excluded value. So that could be cancel that 2, you will have this one, and then apply the properties of exponent r raised to 4 divided by r. So again, dividing powers with the same base, subtract the exponent. So we will have this one as r cubed over 7, and your excluded value is 0. Otherwise, if your r is equal to 0, the whole expression is undefined or meaningless. Another example. First, we need to factor out your numerator and denominator if possible. So here, denominator cannot be factored out, only the numerator. So factor 6n squared plus 3n, which is the numerator in your rational expression. So when you factor out this one, again, 3 is common in each term, n is also common in each term. So take out 3n. So we will have 3n times. How many 3n are there in 6n squared? We have 2n plus 1. Then over, copy your denominator, 2n plus 1. Divide the common factors, okay? So take note here. If you're going to equate the denominator equal to 0, n equals to negative 1/2 is the expression that make your expression here undefined. After that, simplify the given expression. Cancel common factors here. So we have 1, 1. So 3n times 1 divided by 1, that could be 3n, and then the excluded value is negative 1/2 after simplifying. Okay, so here, the simplified form of this one is 3n, and the excluded value is negative 1/2. So when n is negative 1/2, the whole expression is undefined. Take note, be sure to use the original denominator when you find the excluded values. The excluded values may not be seen in the simplified denominator, but rather in the given equation. Okay, let's check this one. Simplify each rational expression if possible. So letter A, r plus 2 over r squared plus 7r plus 10. Letter B, b squared minus 25 over b squared plus 10b plus 25. First step, factor the numerator and the denominator when it is possible. R plus 2 cannot be factored out already. But r squared plus 7r plus 10, we can still factor out this one. Again, possible factors of 10 whose sum is 7. So we can rewrite that one as r plus 2 over r plus 2 times r plus 5, which is the factor of your denominator. In letter B, factor your numerator here. Observe the numerator. B squared minus 25. This is difference of two squares. If you have difference of two squares, the factored form would be b minus 5, b plus 5. In the denominator, possible factors of 25 whose sum is 10, that could be b plus 5, and then b plus 5. Second, divide the common factors or cancel the common factors. So you will have cancel r plus 2, and then the second one, cancel b plus 5. So after dividing the common factors, simplify. So what is left here? 1 over r plus 5. And letter B, that's b minus 5 over b plus 5. If you are asked to find here the excluded value, in letter A, what do you think is the excluded value here? So what is the value of your r to make this one 0? Negative 2. The second one, negative 5. So therefore, in letter A, the excluded values here are negative 2 and negative 5. In letter B, what do you think is the excluded value here? That's correct. It is negative 5 because when your B is negative 5, the denominator is 0. That makes the expression undefined. Okay, recall that opposite binomials can help you factor polynomials. Recognizing opposite binomials can also help you simplify rational expression. Consider x minus 3 over 3 minus x. The numerator and denominator are opposite binomial. Therefore, you can rewrite that one. X minus 3 over 3 minus x is the same as x minus 3 over. By commutative property, the expression, the value will not change. Negative x plus 3. That is the same. Factoring that one, x minus 3, factor out here negative 1. So have x minus 3. X minus 3 is a common factor, so you can cancel that one. What is left is 1 over negative 1 equals to negative 4. That means, in general, if you have a numerator and denominator that are opposite binomials, the result is always negative 1. Let's take this example. Simplify each rational expression if possible. First step, we need to factor out your numerator and denominator when necessary or if possible. In letter A, the given rational expression is 5x minus 10 over 4 minus x squared. In letter B, 18 minus 6r over 2r squared plus 8r minus 42. If we're going to factor out in letter A, what is the common here? Is x common? No. So only 5. So we can take out 5. And then what is left here? That is x. How many 5 are there in 10? That is 2. So the factored form of your numerator here is 5 times x minus 2. In your denominator, this is difference of two squares. So therefore, the possible factors would be the product of the sum and difference of two terms. So that could be 2 minus x times 2 plus x. In letter B, 18 minus 6r. As you can see here, the GCF is only 6. R is not common in every term, so we can take out only 6. So we will have here 6 times. How many 6 are there in 18? We have 3. We take out 6 here, we still have r. In your denominator, you will see that there is a common monomial factor, so you can take out the 2. What is left here is r squared plus 4r minus 21. So find the factors of negative 21 whose sum is positive 4. So that could be 7 and negative 3. So the factored form of the denominator in letter B is 2 times r plus 7 times r minus 3. After factoring, we're going to identify if we have opposite binomials. Here we have opposite binomials, x minus 2 and 2 minus x. In letter B, we have 3 minus r and r minus 3. So you can rewrite one opposite binomial. That could be 5 times x minus 2 over negative 1. Take out the negative 1 and then x minus 2 times 2 plus x. In letter B, 6 times 3 minus r over 2 times r plus 7 times, take out negative 1 here, that is negative 1 equals to 3 minus r. That is the same here. Then, divide common factors. So you can divide common factors by canceling that 1, x minus 2, and here 3 minus r in letter B. Then simplify. We will have negative 5 over 2 plus x, and then we have negative 3 over r plus 7. Next example. Simplify each rational expression and then, if possible, first step, we need to factor out. So in the numerator is 3x minus 33 over x squared minus 121. So is x common here? It's not. So what is the common monomial factor here? That's 3. So we can take out 3. Taking out 3 here, we will have x. How many 3 are there in 33? We have 11. So in numerator, the factored form would be 3 times x minus 11 over. The denominator is difference of two squares. So the possible factors are x plus 11 times x minus 11. Divide common factors. The common factors here would be x minus 11. So you will have x minus 11 being canceled out, and then simplify that one, you will have 3 over 11. Another example. A theater at an amusement park is shaped like a sphere. The sphere is held up with a support rods. A. What is the ratio of the theater's volume to its surface area? Take note, when you find the volume of the sphere, that is 4 over 3 pi r cubed. And the surface area would be 4 pi r squared. You are asked here to find the ratio of the theater's volume to its surface area. So what we're going to do is write the ratio of volume to surface area. So what is the volume of the sphere? That could be 4 over 3 pi r cubed over the surface area 4 pi r squared. After that, divide common factors. We have common factors here, pi. So when you divide common factors, you can cancel out that one. What is left would be 4 over 3 r cubed over 4r squared. Then in this expression, use the properties of exponent. Dividing powers with the same base, subtract their exponent. So we can simplify further that one as 4r over 3. So divide that 1 by 4, that is multiplied by the reciprocal times 1 over 4. Then divide the common factors. 4 is common, cancel out that 1. So r therefore would be r over 3 is the simplified form of the expression. Letter B. Use this ratio to find the ratio of the theater's volume to its surface area when the radius is 45 feet. So again, we will use the result that we come up in A. What was the simplified form to the ratio of the volume of the sphere to the surface area? That was r over 13. Since the radius in this given is 45 feet, simply replace that one. 45 divided by 3, that is equal to 15. We simply write the ratio of the volume to surface area and then substitute 45 for R, then simplify. So the ratio of volume to surface area of the theater is 15:1. So for your exercises, please refer to your weekly plan and person account for your homework. Thank you and God bless you.